this video, I will be showing you an activity which you can use to introduce students to the concepts of magnets, magnetic forces, and how magnetic fields are created by the movement of electrons within atoms. In this activity, students will be playing with magnets. We recommend using ceramic bar magnets with labeled poles such as these. Please see the lesson planning materials for detailed safety information before using rare earth magnets such as these. For this activity, place students in small groups, ensuring that each group has at least 2 bar magnets, but preferably 1 per student. Start by asking students to explore what happens when they bring 2 ends of the magnets together. Ask the students if they can identify what the rules are which determine if the magnets attract or repel. Allow the students to play freely with the magnets for a while before providing additional guidance. After some time, encourage students to test out what happens in the following arrangements. North to north, south to south, north to south, and for completeness, south to north. Ask the students if they have figured out what the rules are. They should be able to identify that like poles repel and unlike poles attract. Encourage your students to play around with the magnets and see if they can identify any other arrangements or interesting behaviors. Some suggestions include what happens when we bring the magnets together side by side like this, or like this. If they place one magnet on a table, can they push it around with the other? What about if we approach the side of one magnet with the end of the other? Can we get one magnet to jump up to meet the other? Students can also see if they can manage to levitate one magnet on top of the other. Although they probably won't be very successful. After the students have finished the activity, they may be curious as to what makes magnets magnetic. Recall that atoms are made up of nuclei and electron clouds. As electrons move about in the electron cloud, that movement produces a magnetic field. So each atom is actually a tiny magnet. In most materials, the atoms don't line up, so all the little magnetic fields cancel out. But in magnets, all the atoms do line up, and the tiny magnets all add up to one big magnet. More details about how magnets and magnetic fields are produced can be found in the lesson planning materials.